We present a user-guided offline method to generate smooth and feasible motion for robot arms to closely match position and orientation goals of a given path. For example, here we see a 7 degree of freedom Sawyer arm tracing a line. Here, a 6 degree of freedom UR5 arm is tracing a 4-sided polygon. We also evaluate our method on more challenging paths like writing the word ICRA spelled ICRA. These paths are traced with very low position and orientation errors. While matching position and orientation goals are important, there is danger of self-collisions, kinematic singularities, and joint space discontinuities. Our method ensures smooth transitions as shown on the right, feasible trajectories throughout, and in more challenging cases, relaxes position and orientation to meet feasibility goals. Here the goals shown in green are relaxed and the robot arm traces the path shown in black to avoid self-collision. This is an example of a path similar to the one shown in the beginning of the video where the robot writes the word ICRA. This path has been moved closer to the static base of the robot, which makes it more challenging because of the danger of self-collision. In this case, our method uses user input to determine the kinds of deviations from the path that are acceptable and generates a trajectory that can be safely run on a real robot, as shown on the left. The input path is shown on the right in green and the output path in black. The output path followed by the marker is an approximation of the input path, but still reads as ICRA. Our evaluations on many other challenging paths show that the output trajectories honor kinematic and path constraints within the limits prescribed by the user.